us as we move along. We'll begin as we are for those who are really keen on learning, and I hope you are ready to learn. Okay, I do hope you were with me in the last session. If not, I hope you have seen the recording that I provided. If not, you cannot see it in the group. It is right now in the backend group, and I don't know which other group I shared to two groups. Right now, you can check on the backend group, and there you're going to see the link to the recording of the last class. You can check it after this class, and I will also record this class and provide the link as same as before. And for the search class, we carried it quite a while back. It has been around a good couple of weeks, like 3.5, 4 weeks since we last had our last class. I'll improve more on this. I had to concentrate on the front-end classes that I held every week. But now that I've taken a short break this week, I'm going to cover it. Next week, I'll continue back with my front-end classes. But for today, we continue with the next installment in the data structures and algorithm classes. Now, this second class, we are covering sorting algorithms. As I said in the last one, I hope you remember what said algorithm is just the steps we do to do any task. That's just an algorithm. And we covered such algorithms last time. I use such algorithms to look for an element within a list or an array or that. And now with sorting algorithms, it is in the name, so you order elements in a certain specified order, ascending or descending, whatever order you describe. And I hope you are ready to learn, and let us begin. I do hope I am audible, and let us start. So, what will we cover today? So, obviously, we have to introduce ourselves to what sorting algorithms are. Then we'll cover three of them. There are very many sorting algorithms that exist, but we are going to cover the one which people know most: bubble, quick, and merge. Bubble happening to be the slowest of the sorting algorithms, and quick and merge, which are the fastest of the sorting algorithms. We'll cover them in depth. We'll have a small coding session after each section, and hopefully through it might take a while, so I hope you're ready to learn and ready to stick around till the end of this class. Now we can begin. So, sorting algorithms, what are they? As I said, algorithms are very crucial as a developer. You need to understand them. They are really essential, especially for people working with back-end stuff and also occasionally with front-end stuff. It is very essential to understand how these algorithms work. And I will cover it using Python, but for those who don't care about Python, you can go and research, and you can also implement them in many other languages, from JavaScript, C, Rust, all that. There are many ways to implement in every language, but for now, we are only going to focus on Python. So, sorting algorithms are fundamental tools for organizing data efficiently. They are pivotal in tasks like searching, optimizing data processing, and visualization. Now, if you remember the last class, I did say that binary search is the fastest search algorithm you can use, better than linear search, among others. And I said that the only way you can use a binary search is upon a list that is already sorted. That's why we say it is very essential for searching, because you can sort the list first before you have to sort it first. If you don't use binary search, which is the best, you need to sort it first before you do the searching. Now, for data processing, that's another thing. With ordered work, you can process data faster. Visualizing data properly, you might need ordered stuff. So it's very crucial, especially when you're working with as you work constantly on bigger and bigger projects, you'll end up encountering them a lot more. So as I said, we'll cover bubble, quick, and merge sort. We'll examine their logic, implementation, and real-world application, how they might work, basically as we code it through. Now, I hope you are ready, because we're about to start with bubble sort. Now, bubble sort in itself is a simple algorithm. It's very simple. The problem with it is very inefficient. Bubble sort repeatedly swaps adjacent elements if they're in the wrong order. Suppose there is a list that you have, and this list itself, it has like maybe 2, 5, 6. How you can start bubble sort, you're just going to relate 2, 5, and then if now you see this is bigger than the other, you switch them. If you want it in descending, you switch the other way. Basically, that's how bubble sort works. Basically, it's the sorting algorithm you can just think of out of your mind. Very easy. Problem is, as you can guess, it's very efficient. The easy stuff always the most inefficient. Now, It's best for small and nearly sorted data sets due to its time complexity. Don't worry about this complexity. I typed it wrong. Should remove some of that. Sorry for that. It should just be on squared. But basically, don't worry about time complexity. Right now, that's the topic I'll cover in the next class, so you can understand time complexity properly. So don't worry about this. So we call it quadratic because it's one of the slowest to execute. I think it's basically the slowest sorting algorithm you can use that is well known. Now, if I can switch to VS Code, give me one moment. If I can switch to VS Code, this is okay, well, this laptop of mine. Give me one moment. Give me one moment. Let me share this window. Okay, here we are in our Visual Studio, and we are going to implement bubble sort. So that you can guess, as I've told you, it's a very, very easy language to a very easy algorithm to master. So now let us begin. So you're going to create a new file here. We're going to call it bubble underscore sort.py, and let us begin. So we are going to create a function that's going to perform the action of sorting in the list that is applied to it. So what you're going to have, you're going to declare a function called bubble sort, and it's going to take an array. Let's choose an array. Why not? So you can work on lists and arrays. Don't worry, you can use any of them. There's no problem. But we are going to use an array in this one, and let's go through it now. So for n, that it may be array, but don't worry, it's just going to be a list. So you know it's Python. Python lists and arrays are the same thing. So first of all, even my AI is trying to give me the answers immediately. First of all, we are going to look for the length of the array, because obviously if you want to iterate over each element of the array, we need to know how many they are in the first place, so you don't go over the border, we don't exceed the index of the existing elements of the array. And now we are going to iterate. You're going to create a for loop which iterates over these elements and arranges them into the order we like, whether ascending or descending. So as you can see, even the AI is telling us what you're going to do. You're going to create a for loop I in the range of n, and we are going to write our function here. But first of all, you need to iterate repeatedly. So you're just going to go again over j from the range now. Now we're going to go a bit less. So we are going to start, oh, sorry, this spelling of mine, from 0 going on to n minus I minus, sorry for that, 1. And then, don't worry, I will explain it as we finish up. And now, think about it. Now we are going to compare now. If now this is bigger than this, because we want to iterate over there, we're going down the list. So we want to iterate over with the elements from the start to the end. So we're going to relate the first one with the second one, so on and so forth. So we are going to start if array at the position of I and is greater than, no, we are relating the other way around. Let's just use j. No use using I. J is greater than array at the position of j plus 1. We are now going to check now. We are going now to iterate. We're going to alternate basically. We're going to take from one position. Basically, if this is bigger, the second one is bigger than the first one, we're going to take the position of the bigger one, put it at the position of the first one, and then the first one at the position of the bigger one. So we're just going to interchange it. So again, array now at the position j, and the one after it now, which is array at position j plus 1, is going to be equal to array at position j plus 1. This underscore should not be here. Plus, comma, array at j. Maybe be curious what you're doing here. Basically, is that you can think you're just saying, alternating this here to be, okay, this, yeah, this here will be replaced with this one here, and this one will be replaced with this one. You can see at the position how you have positioned it, and they're going to alternate. In a C, you can put them into a tuple, but in Python, you have the ability to just write it immediately as is. And then now we are going to return we are going to, okay, this is the wrong, we need to be outside completely. We're going to return the array. Oh, sorry for that. Now, let's get down here. Now, this is our function. So now we have to ask ourselves, what have we done? So in bubble sort, as I said, you compare the element one with the other one after it and see which one is bigger than the other. If you want it to be ascending, we are going to, or descending, now we decide we are going to switch them or not. That's what this function is doing basically. So first of all, we assign the length to n because we want the length. We want to know how many elements exist so that we cannot go to the, we don't continually iterate till the end of the array. Next, we start a for loop. First of all, for the I, we are going to start from 0 to n, and the inner loop is going to start at 0 to n minus 1 minus I minus 1. I know you might be asking, what does this imply? So basically, let's say we have an array. Maybe you can just write it down here. An array is equals to, let's say, it's the list basically. I stop calling it an array. This list, you're going to maybe have 4, 7, maybe the 2, 9, 8. Doesn't really matter. You can leave it as that. And then now we come here and we call the function, which is a bubble sort. I think you can print it. We don't have to return it. You can just print. You can just print it. All you can do, you can just print it. We are just going to print from bracket. We're going to print now. Let's just print the array, the R or list, whatever. Now we come here and we run the function bubble sort, and then we assign it array. Now what is happening here? Array will be taken in. The length is taken, and then we start iterating. We are at j. J is starting at index 0, basically. And then we go to array j plus 1, which is at the index 1. So we come here, 0, index 1. Okay, now we ask ourselves, if index 1 is great, index 0, if index 0 is greater than array j plus 1, which is 7, which is index 2 now, what do? We switch them around. If they're not, we're just going to continue down the loop as we iterate. Because as you can see here, basically we are starting at 0, we go at 1, now we compare 1 and 2, so on and so forth until we get to the end of the list. Bubble sort is not a very hard algorithm. Even you don't have to explain much because it's a very easy algorithm to learn and implement yourself. And that's why many people don't. It's very inefficient because you're constantly iterating. You compare this, you change. If not, compare this. It's very, that's why you say it's small data sets. Because if you have a very huge data set, imagine you have 1,000,000 elements. They're going to take a very long time because you are comparing this over and over until the end. Then you start again going interchanging. That's not a very efficient method of doing it. Because that's why you say it's all log n log. Okay, I don't have to go into that. I'm going to confuse you. So what I'm saying is it's a very inefficient algorithm to use. Now, let's go on to the next algorithm, shall we? Give me one moment. Let me go back to this slide. Okay, that is bubble sort. Now let's go on to quicksort. Now, quicksort and merge sort, as I said, they are among the fastest algorithms for sortings and the ones people mainly use whenever they are sorting stuff. So again, this typing error, don't worry about that. So, I'm going to the next one. So what is quicksort? Quicksort basically uses the divide and conquer method, where it partitions the array around a central area, a pivot, and recursively sorting the partitions. That's what it is. You might feel it sounds a bit like binary search, but it's not close enough. So basically, just divide and conquer. As I said, this is an approach. If you have learned if you're taking a course in IT or software engineering, might have had this concept. We take it a lot of these algorithms that do a divide and conquer. They split with maybe in half, in segments, then do and combine later. It's called divide and conquer, where now you start at the center and recursively sort the partitions and combine them in the end to form a sorted list. That's what quicksort is. And it has an average complexity of O n log n. For those who know mathematics, they know that's a very smaller number than O log n squared, which makes it very efficient for large data sets. Now getting to the more efficient algorithms. And as I said, some of them become a bit more complex. But for quicksort, they say it has gone that much high in complex. Don't worry, we'll cover much so soon, which happens to be way more complex than any of these two. Now, let's go on back to Visual Studio. Give me one moment. Give me one moment. I set this up there. Now, quick sort, as I said, this uses a divide and conquer method, which is splits in half, then sorts, then combines later. So I'm going to create a new one, which is going to be called quick sort.py. That's .py. Now, as I said again, you're going to create a function which takes the list. Just going to continue to call it array. Why not? For those people, let's just continue calling it array for those people who are going to use other languages, because it's not only Python that is used. So we are going to use this array stroke Python and stroke list, and we are going to apply it into a function as we did in Bible sort, and we're going to sort it and produce an output. Now, let's get down to it, shall we? Now, as we start again as before, we create a function called quicksort, and in quicksort now is going to take again an array slash list. Now, let's ask ourselves, what do we need to do? Well, if you want to sort in this, it's better we confirm that the array that we have is actually full. You know, in a bubble sort, it doesn't even really bother much. It's just going to return you an empty list. But in quicksort, sometimes it might cause some errors. So first of all, let us check if let's run a test first of all. If the length of this array is less than or equal to 1, what do? We return the array as is, because, you know, there's nothing to sort if it's a bit empty. You can actually implement this body in the bubble sort, but I never really bothered for that, since an algorithm I doubt will really use ever in your life. Now, as I said, you're going to divide the list or the array, whatever, among in a pivot. You're going to determine a pivot where we are going to split it at. So you're just going to say pivot. Won't call it pivot. You can call it midpoint. Let's just call it midpoint. In the end, it is a midpoint. Midpoint. Now, what will midpoint be equal to? Obviously, you're going to take the array that we have. Then we take its length, because, you know, you can't divide something by half if you do not know its length. The length of the array now, then we divide it by 2. That is it. Seems to be an error here. Let me. Oh, this is it. Let me return it back there. Nice. Sorry. Yeah, it was just a bit inside. It was confusing. If it was in the if, it considered itself behind the return. Don't worry about that. Now that you have gotten the midpoint, which is at the center of the list or array, now we go to the next part. Now consider this. Now we are going to order this stuff. Obviously, that if you're not ordering in ascending or descending, we have to either push them on the left side or on the right side of the list, either ascending or descending. So what you can do simply, we are going to declare 3 variables: left, middle, and right. And for those who know Python, we're going to use a closure. I guess you can. I'm used to calling it a closure, even if it's not. It's a single line for loops, if statements, all that. So now the left is going to be equal to, now let me show you how we write this stuff. X for X in the array, now the array that we have, if X is less than the pivot. Now what does this mean now? So X, now you're iterating over this X value that you have assigned here. Now it's X in array, the element that you are beginning at. We're going to start at 0 automatically because we're not declaring a range. So X for in array where we start at 0, and we're going to iterate till probably the end of the array. And then, oh, it's not pivot, it should be midpoint. I forgot to rename it. Midpoint. There. Now X for X in array. Now, if X is less than array, so what you're doing in this left, you're creating a list or array, whatever you call it, which will contain elements. Now, the elements, how they're going to be arranged now, if X is less than the midpoint, you're going to push it to the left. Basically, you're dividing it by half. Half of it will be in the left side, and then you're going to have the right side, which is going to take the other part. Maybe you can divide it into 3, you can have the middle point or that. Basically, just taking the things, anything below the midpoint will be put in a list called left. That is it. And we can do the same now for maybe, why not, the midpoints now. Let's just call it the middle, why not? Middle, and again, use this. You can teach yourself this. They're very easy to learn. They're very easy to learn. There. So what have we said here? We want the middle, obviously the midpoint, to be x for x if array if now the x itself, if the x is the midpoint, we're just going to put it here. Just going to be one thing, the midpoint, that is it, which is not going to be assigned to a list with one element, which will be the midpoint. That is it. And then now we can go to the right side, basically, which is just the same as the left, just tweaking a few things. Now again, x for x in array if x is greater than midpoint. That is it. You don't have to include the middle part. You can choose to leave it or not. I'm just leaving it here for those people who are working in other languages, so you can see how you're following along. So if you can just, don't even actually need it most of the time, but I'm just going to leave it. And now that you have assigned now to the left and to the right and all that, what do you want to return? Basically, we want to return, 1 second. Okay, this I didn't remember, but let's type it out properly. Now I want to go to return the quick sort now, left side plus the middle with this plus the middle plus quick sort, and then we have right. Now, what are we doing here? Now, what are we doing in the quick? This is called a recursive function. For those who know Python, as I said, for this, to understand this sorting algorithms, you really need to be in an intermediate level in Python. But you can come back to this video later. But recursive functions are functions that call themselves iteratively, basically. Now, what we are running here is we come with the first array, we put to the left side, we have a middle list. That's why I chose to use the middle as a list, so I can just add it in instead of having to convert it to a list later. Just easier to do it this way. And then we come here to write again. Now we have separated them. We have a middle point. Anything below middle is in the left. Anything after middle is in the right. Then we come here. We run the function again. Then we put the left side. Now the left side is running again. It is separated constantly. Basically just being, as I said, you are splitting it into parts, then ordering them, and then adding them to form a cohesive list in the end. That is it. That's what we are doing with quicksort here. And we run it until basically it's going to stop when the elements, you get to a single element list. It's going to stop. Then now combine them in the end, as it continually combines them until we have a list that is properly ordered. Now, again, we need to test this out, obviously. And I know you never tested bubble sort. I don't really care so much for it. We can even test it. By the way, I don't think we tested it. I think we tested it. Just to confirm, let us test it. As you can see, it ordered from in ascending order, and quicksort we are going to do again in ascending order. So we come here, we again declare maybe and the array is equals to. We don't even have to type all this in. We can just copy this, put it down here, and then again we call. Oh, I returned it. We are not calling a print. We're just going to print. We're going to print. We are going to print that. And then here we again go quick sort. We assign array. We save. We run. Oh, this. Oh, sorry for this. I shouldn't Control Z. Z. Now we come here. We can return it and then print. Let's just come here and just write a print statement. It's no problem. We're going to print the quick sort with the array. Why not? And now there's not going to be an error. Oh, there needs to be 2 brackets. This completer. Now there we have it. It is sorted again 2, 4, 7, 8, 9 in ascending order. And like that, we have implemented quick sort. Again, it is used here and there. It's also quite simple if you ask me, as long as you write it this way. Normally you just write the for loop, then instead of the for loop you write the if statement, but you can teach yourself to write it this way. It's very efficient. Actually, I like writing this way these days. And we can go on ahead to the important one, and the one I would say we concentrate a lot of energy on. I want to go it as easily as I am doing this too. Let's go to the next part. Let us go to the next part. Let me share my window. This laptop. Okay, merge sort. Now, it is a stable divide and conquer algorithm, as quick sort, that splits arrays into halves, sorts them recursively, and merges the sorted halves. This is now the one that would say it's more closely aligned to binary search. And I would say this one which is used a lot. And as you can see, it is consistent performance with a complexity of ON. And this is the reason I guess I added two of them, because it's ON as it works. Oh, sorry for that. We'll come back here later. O log n, ON log n, which is basically a very small, as you can do mathematics, you can see this is a very small number that is obviously smaller than the bubble sort and most other algorithms. And it's obviously ideal as quick sort is for large data sets. But now, where merge sort shines more, it is used a lot in linked list. When I cover linked list, you actually have to come back to this merge sort. And once we come back to this merge sort, we are going to when you come back to linked list, you're going to teach. We're going to learn implementing merge sort in linked list. So you can expect that in a class. It will be later on in the year probably, as because you have to cover time complexity first. Then you can start on the data structures sections. Now, let us go on to the code. This is going to be a lot more complex than before, because I'm going to really, unlike the others have done, we are, this is annoying. So, unlike the others, we are going to take our time with this merge sort, which is going to take a bit more time, like at least twice the time we've used on the others. So, let us begin. Merge sort dot py, and now let us begin. So as I said, merge sort in itself, it is still the same as quick sort when I said it is a divide and conquer method. That is all it is. Nothing complex, nothing. Okay, it's a bit complex, a bit more complex than quick sort, but it is actually this is the most important one for you to master. I won't even use closures in this one. I'll just go on directly and show you the long function as they should be. So we're obviously going to, as again, we're going to have a function. We're going to call it merge sort. Obviously, we're going to call it merge sort. And merge sort here, we are going to put in a list here. Just going to use the normal way so you can follow in through and through in this one. Now, we want to sort this list in ascending order, okay? And now, this function is going to return a sorted list. So, first of all, we are going to divide, conquer, and combine. You're going to find the midpoint of the list and divide into sublists, basically. We're going to, again, as you saw we did in quickly, just going to divide to sublists. Next, we are going to, the conquer part, you're going to recursively sort the sublists created in the last step. That is it. We are going to recursively sort the sublists, and then we create until the last step, and then we are going to merge the sorted sublists to create a new sorted list. That is it. And by this, we're going to achieve the ON log n time that we wanted. It's a very fast and efficient method. Might be a bit complex, but we do not really mind. Now, as I think we can even write doc string for this one. Why not? We're going to write doc string for this one. Is that 6, 1, 2, 3? Now, inside here, we are going to write what we want. You should teach yourself to really master this stuff. You master doc strings because it will be very essential when you are writing functions. So you can even consider this a class about writing doc strings. Why not? So this guy is going to sort the list in ascending and return sorted list. That's what you're doing, basically. This is what this function will do. And let's come here and begin. You can write more stuff here. These are like mine. There's a better way of writing the doc strings, but this is sufficient enough. And now, first of all, we're going to run a check, obviously. So now, if the length of the list is less than, wrong place, is less than or equal to 1, basically, we don't really want to worry ourselves about this list. If it's 1 or below, we don't really care about it. We're just going to return it as is. No use wasting resources for a list that is basically already sorted. Now, we are going to separate again to the left, right, so on and so forth. So basically, we're going to have a left, we're going to have a left half and a right half. And now here, now what I'm suggesting here, to make our work easier, I think it would be good as even as programmers as we could, where you separate different functions into different other, you can separate different functions to other, different actions to other functions. So like we can now assign the action of splitting left and right to a function. We're going to call it split, and it's going to take a list. And down here, we can just call the split function here. And again, it's going to take list as it was stated there. And we can come back to it later. Oh, sorry for that. That's this. And we can come back to it later. Don't worry about this. Let's worry about this part first. Now that you have separated the left and right half, we are going to now declare which the left and right parts are for this. Now, the left, now you're also going to separate this action to maybe the merge sort function. We're just going to call it merge sort. This merge sort function, left half. I hope you remember what you're doing here. Merge sort, recursive functions. We're using them again. They're very, you're going to see them a lot, especially when you're working with stuff like this. They make very nice workings of this stuff. So now you're going to declare the right side is equals to merge sort, the right half. We're just reiterating again and again as we did, as we are doing here. We're just assigning them again left and still maintaining which side they belong to. Now, we're not going to just, now, why not, why don't we, this is already giving me what I'm going to return. Now, in this function, we are going to return again, we are going to separate the action of merging these lists to another function. We're going to call it merge. And it's going to match the left side and the right side. Why not? That works out. And there we have our merge sort function. Going to back. Now, we have the split function. Let us implement it. That's the first one here. Yes, it's the first one. So let us begin with the split function. So now does the split function do? As we said, the split function is going to divide the unsorted list at the midpoint into sublists, and it's going to return two sublists, the left one and the right one. As you saw here, we assign the left and the right to the list, so just to return the left and the right sides, both of them is going to return the left and the right. Now, again, we use docstring 1, 2, 3, and it's going to again divide unsorted lists at the midpoint, and it's going to into sublists. Why not? Into sublists, and then it's going to return left, right. Basically, no use writing it in full. Now let us implement this function. Now, first of all, we have to understand the length. We have to understand, you have to really know the midpoint of the list. And as we did in quicksort, what we are going to do again is declare the midpoint. Let's go to the length of the list. Then you're going to divide it by 2, obviously. Now we have the midpoint. We are going to set it to mid. Why not? And now we're going to assign the left, because you have to return the left and the right. So what will the left be? The left would be the list. Now let me tell you, I've forgotten the name of this action. It's how you can take a specific part of the list. You can separate a list into, you can take a specific part of a list and assign it somewhere else into another list without having to run a completely different function that maybe separates, or maybe a for loop that separates. So let me show you how this works. You're going to left. It's going to be the list. Now we are going to start. What this means, it's everything. Now, anything before, up to mid, basically. Anything from the beginning at 0, that's why we have nothing here. You can even put index 0 if you want, but you don't need to. So it's anything before 2, the midpoint, that's where we want to go. So this side will be the left, basically. And then now, finally, we can now go to the right. And for those who can guess what you're going to do again, list. But now we are starting from the midpoint to the end. That is all that means. It's not that complex. All this means is that we're going to take the list, and then anything before mid, it's from zero, index 0 to mid, is going to be put to left. Oh, Control Z for that. And anything mid to the end of the last index is going to be assigned to right, obviously, the left side and the right side. And now we can return again left, right. As I said, we return this. Left is assigned to the left half, and the right is assigned to the right half. Now we can go on to creating the merge. Now we have finished the split function. That does not really matter. This entering there. And let's go to the merge. And merge, as you saw here, merge takes a left and a right. Again, it takes a left and a right. Oh, have I spelled that correctly? Right. And now we are going to, what are we doing now? Okay, now again, the docstring part, we need to now understand what this function is going to do. So merge is going to merge two lists or arrays, sorting them in the process. This we are going to be sorting, merging. That's what it's doing. This splits this sort and merge immediately. That's what we are doing, and it returns a newly merged list. Basically, now let's again docstring. And we come here. We're going with merges. And care about capital. Merges two lists while sorting them, and then returns merged list. That is it. And now we can begin. So we're going now to iterate, as you saw we did before in the for loops in the quick sort, where we iterated our I and J. We're just going to do the same here, but let's spice it up a bit. We're going to use while loops to implement the merge sort. So we are going to the list you're going to create, you're going to assign it to an empty list, and then I is equals to 0, is equal to 0, and J is equals to 0. And now we start our while functions. Now, while I is less than the length of the left side, and J, don't worry, I will explain it right now, is less than the length of the right side. So what we're doing here, we're just saying the I here, while it's less than the length of the left, you're taking this left here. If I is less than left, and also J is less than right, so that now we can start merging immediately as we move on along. If the left at position I is less than right at position J, don't worry, I will now explain it as a whole. Let's just follow along, then I will explain. We're now going to append to that list, this list we created here. Now we're going to append to it the left. With this bracket, it is. We're going to assign it to the left side at position I, and then I is going to increment plus equals 1. And again, we are going now to check if it's the other way around. Else, this is 9. Else L dot append at right at position I. Now that you have now, okay, now let me explain up to here so that you can now understand. So I is less than the length of the left. This I, we are starting at 0, so it will obviously be less than, and J will obviously be less than right because we're also starting at 0, because we have already passed this point. So obviously our list is bigger even than 1, so we are going to continue onwards. So if the left at position I is less than the R at position I, so we are comparing now. If we have taken now, if you remember at the merge here, we took the left and the right, and basically now that you have the right side at position I, now it's bigger than the right at position J. You are going to build, and you are going to append now. Where at you're going to append Li because it's less than. What does this mean? Because maybe it's we are comparing 2 and 4. because 2 is less than 4, we are going to attach it first of all, obviously, before we attach the right side, obviously, because the left is smaller than the first left side, the first element of the left list is smaller than the first element of the right list. Now, if it's the other way around, now that the right one, the one for the right is only smaller than the one for the left, we are going now to append it to the list as the first element because it is obviously smaller. We are going ascending, so it is smaller to the largest. That's what we are doing. And now that we are going on, we are going to create a new while loop. Don't really explain all of them in a whole. While I is less than the length of left, what are we going to do now? We are going to append L dot append left at position I. Now we can now increment I again plus equals 1. And now we check the final one while j, now the other way around, is less than the length of right. What are we going to do? L dot append right j, and then you're going to increment j. And finally, as you can guess, you're going to return L, the list that you have created. Now, let's go over what we have written. So we are running this merge sort function. What it does, first of all, it checks if the length is 1. If it's 1 and below, we are going to return list. So do not waste energy sorting something that is basically sorted. Then we split the list to the left. Okay, I don't know what the hell happened here. I don't know what happened here. Left half, right half, right half there. Okay, now that's sorted. So left half, right half, as it's written here. And then you're going to run the split function, which splits the list. Not a split do, we come here, it divides the sorted list, we get the midpoint, the left side goes here, and we get the right side, then we pass it back here. And now the left has been taken, the right of the left and right side of the list have been taken. So now we are going to put the left calculations for the left half through the merge sort function, and the right again to the right half. Again, you're just splitting basically. You're just splitting it constantly especially when you go to the merge part. You're just splitting. That's what you're doing. And then now we are going to put them in the left and the right, and then you're going to run the merge function. Not as the merge function do, as again it takes the left and the right side. So we get a new list which you're going to return later. Then you're going to get j, which you're going to return later. I don't know what this is doing here. Then j, again, okay, we have I, which is set to 0, and j, which is set to 0. We are starting an index 0 for both lists. Now we are going to start the first check, where if I is less than the length of the left, and j is less than the length of the right, because if you split them equally, they are going to the same size. So you don't want them to go past the list themselves that they are assigned to. Now we are going to start running this. If now, again, the first element of left, or that element we are starting at 0 as you go 1, 2, 3, 4. For that element, if it is smaller than the right first element or that element we are going to append the smaller one, obviously the left I, to the new list. Then we're going to increment I because we have moved on from that. But else, obviously, we're going to do the vice versa. We are going to append J. I don't know why I wrote that like that, but we should be appending J. And now that we have appended J, otherwise we are going to include. I actually forgot to increment J here. Sorry for that. You should increment now because you have moved on from that. Then the next check now is while now again I is less than the length left, and you're going to append left I, and then you're going to append while j is less than the length again of right, we are going to append j to that function. And I will go on like this, splitting, sorting, merging, splitting, sorting, merging, splitting, sorting, merging, until we have a cohesive list that is sorted in the end, which are going to return here. Now, why don't we create let's go the extra step and create maybe a function that verifies our sorted list as we did in the search algorithms class. So I'm just going to call it define. We're going to call it verify. If it's sorted, we're just going to verify sorted. And then where is this going? I see. So it's going to take in itself a list, which you returned here. It's going to take a list. Then you're going to get the length of the list, length of the list, length of the list. Then you're going to check if n is equals to 0, the length, or n is equals to 1. You're just checking if, if it's 1 or less, there's nothing wrong with that. You're going to return true, obviously. If it's just one element or no elements, it's basically like sorted. They're just going to just set it automatically to true. And then you're just going to return, otherwise, you're just going to return, basically, a check if list at position 0 is less than the list at position, the first one, the second position, and we recursive recall it again, verify the sorted list from 1 going onwards. Now this is it's a simple one. Now we assign the length of the list to n. Obviously, if it's 1 or less, you can just return true because it's basically sorted. And then this is a checker here is going to return true if this statement is true. And what it basically means here, I should be one that. Now, closing bracket. Now, what this does is we are starting, we are going to come here at position 0 and at position 1. We are comparing if basically this at this position, if at the first index is less than the second index, it's true, then we try again. And if any of this statement, basically we are repeating the experiment, but now we are starting from now the first position. Basically, the original index 1 will be put at index 0, and now the index 2 will be put at index 1. We compare again, and we continue like that till the end. It's going to compare, and if all those statements end up true, the resulting statement will also be true. And why is there an error here? There should I forgot we need to have the list here because that's what we're iterating over. And now we can test this. Now we are going to have a list which is going to be let's just call it array. Let's go back to good old array. Why not? We're going to have maybe 23 to 34, 56, 100, 67 to 5, and why not? Let's add 60. Let's add maybe 75. Let's add 45. That works. That's we are going to have to sort now this list. So we are going to now first of all attach now a new list so that we can check it, the verified. We are going to create a new list which is now going to be the merge sorting algorithm, and it's going to take now this array that we have, and we are going now to check if it is properly sorted by now running a print function here, and we are going to run the verify sorted and attach L into it. And like that, we have our sorting merge sort algorithm. So you don't have to go this complex. There's actually much easier algorithms out there. I can even ask if they're going to give you a very, very easy implementation of it. But I went through this how you can try and understand how merge sort is done. All you're doing is we are going to split it. Then we are going to continue. We are just splitting it constantly attach the left and half. Then we are going to test it. Now we come here, we merge it, we run again, we split, we merge over and over until we have a final list that is sorted. And we can't be sure if this works unless we run it. Let us run. True, it's sorted, and I think it'd be good also let us run another print function here, which is just going to contain L, so that you can see how it is. There it is. Now we have 2. Now you can see it's ordered 2, 5, 23. It's ordered in ascending. All you have to do to now here we have now the merge sort, we have the bubble sort, and we have the quick sort. Those are the 3 main algorithms you're going to meet along. There are many other algorithms out there, but these are the main 3 you're going to meet. Bubble sort for many educational purposes, merge sort which is used almost everywhere, and quick sort which is also used but not as much as merge sort. Now, where were we? Let me share now. We finish up on the slide sections. Oh, there. This is the wrong thing. Share. Let me share this window. I do believe it's being shared now. Okay. Now, for now, comparison. Obviously, we need to see where each fits where, which algorithm is better for which cases and all that. This is just a summary of these algorithms. So that if you only care about the theory and not the coding right now, you can now know we can understand them a bit more. Now, again, for bubble sort, don't worry about the time complexity. But for the best, it's ON. It's basically, I don't know what has happened there. It takes ON. Don't only all this. I will come back to this table again as I will come back also to the table of such algorithms to explain them in depth. I won't cover this part because I don't want to confuse you in any way. So now, where is this going? Now for the comparison here, first of all, let's cover the use cases. For bubble sort, as I said, it is used for small and nearly sorted data because it's very slow and very annoying to work with. Quick sort for large and random data sets works very well. And now we have merge sort. Now, large data and especially linked list. This is where you get to use a merge sort. Now we have stability. I want to explain to you what stability here means. Now, what I mean here is whether the algorithm preserves the order of records with equal values, basically. Like a stable sorting algorithm, basically, is one where if two elements are equal, their order is in the sorted output will be the same as the input. Basically, if we had, you saw how we had that list, maybe we had two 67s, how you saw they were ordered as they were, when it comes to the first 67, you just alternatively just change it or delete it or the existence of 167 when you make the list. So when you are making the list, as you can see, merge sort exerts that bit more of a quick sort. Where bubble sort will maintain the stability and merge sort will, but quick sort will not. That's why merge sort is not as favored as merge. Quick sort is not as favored as merge sort because merge sort is able to keep the if there are two 67s, how they are ordered in that list will be maintained in that order. None will be deleted and they will be stabilized. Now, that is it for this class, and that is it for this class. And if anyone has a question, you can go on ahead and ask. Anyone with a question, you can go on ahead and ask. Anyone with a question? Okay, then. No worries about that. If you have anything to address, you can come to me. Oh, they seem Isaac. Isaac, go on ahead. Go on ahead. Ask your question.
Good evening. Yeah.
Good evening.
Yeah. So as a novice, yeah. Sorry.
Yes.
What is expected? Should we major on the three algorithms or just one for let's say entry level jobs and in interviews? Thank you.
I can actually tell you it's better you know all of them. Obviously, merge sort is one you can really focus on. But for like something like binary, the bubble sort is a very easy algorithm. It's something you can learn, and you're probably going to have to tackle that first. As I said, it's used for educational purposes because most people when they're learning the sorting algorithms, that's where they already start. Even that's where I also have started there. Which is a very easy way to implement a sorting algorithms, especially if you're working on your small app with a few people here and there. Maybe they might be sorted. Maybe you're trying to maybe have a database you want to sort the IDs properly when you're printing them. You can use like this algorithm here. It works okay. And but obviously in the end, merge sort and probably quick sort will be the ways to go. But merge sort, I would say, is the one you should really focus on for the most part. Is that okay?
Yes, thank you.
Okay, then. Anyone else with a question? Anyone else with a question? Anyone else? Okay, then. And for those who are beginners in Python, I believe I had a recording for the the introduction to Python class that I had held, and hopefully provided for those who seek it. This meeting has also been recorded, so you don't have to worry about that. I will also have the link for this, and the other link for the first session of such algorithms has already been provided. And for these sorting algorithms, as I said, yes, they might be a bit more advanced, but you can go on, learn, come back to these videos later. You can even go on and search through YouTube. There are many videos there. That's also I learned. And you could learn and you practice them, because there are many other algorithms there. You can be curious, go and learn all the algorithms. There's nothing wrong with that. You're just going to impress those big people there and show them many ways to implement the algorithm. And it was like even a faster one out there is that we just we basically use merge sort, basically because it's already available, easy to very a bit that's kind of easy to implement, and that's why we work with it. And I can implement this algorithm in many languages. Actually implemented this sorting algorithm first of all, algorithms in C first of all. They are basically the same but most of the time in Python most likely to be a way simpler than that in merge sort. I just go know that way for the people who are using other languages, so they go and implement it can be done so. And I will aim to create a GitHub repo which I will store the files for these classes, and I will store also the slides that I used in these classes, and also the links will be put up there so that for those people who want to learn onwards, they can access it. Thank you for attending this class. I hope you have grasped something. Even if you haven't, maybe you have gotten curious and now want to learn on someone who might teach it better than I am. Go on out there and learn. That's what I can say. Thank you, and have a nice evening. See you in the next class.